Assalamualaikum and hello everyone. My name is Nurul Aisyah binti Ramlan and I'm creating this video to introduce my final year project titled Design on Lightweight Chassis for Electric Vehicle with Two-Stroke Engine. So this is all the content that I want to elaborate in this video. So first of all is project background. So as we know, nowadays electric vehicle is commonly used because of some advantages that they have, like it can reduce carbon footprint and it also can control emission. So electric car is famous right now because of these two advantages. So global right now struggling to reduce carbon footprint and reduce emission. So that's why many manufacturer introduce electric vehicle. So my research background is to design a chassis for electric car, and the chassis must lightweight and suitable for electric car. The reason why the chassis must lightweight because we need energy efficiency, and the chassis must suitable for electric car due to its component, additional component like battery pack, and then the chassis can withstand high stress. Another important thing that need to be explained for my project is problem statement and objective. So the problem statement of this project is nowadays global struggling to reduce fuel consumption due to the increasing number of vehicles on the road. So many manufacturer or automotive automaker implement this method to increase electric vehicle. So many consumer use electric vehicle nowadays. So for use the electric vehicle, the chassis is the foundation of every vehicle, especially electric vehicle. So the design of chassis itself need to be lightweight design, improve vehicle performance, meet structural requirements, and high stiffness and strength. As usual, every project have their own objective. Same goes with this project. My objective is to distinguish the important parameter of designing chassis for electric vehicle in terms of battery pack system, because of electric vehicles so need battery pack, and then of triangulation design. Triangulation design is a concept or design principle that can increase stiffness and strength of any structural member, the structural member of the chassis, and then to design a lightweight chassis that can withstand weight and stress. So to get the lightweight chassis have their own parameter to be manipulated, like materials or thickness, and then to construct compression stress and torsional stress analysis of the chassis by using finite element method. So the scope of this study is first, the chassis is designed for a passenger car that have two number of seats, and the two number of seats is include driver seats. Then the chassis capability can accommodate weight under 800 kilogram. The class of car is hatchback class, due to its small size and lightweight, because we need to accommodate weight under 800 kg, like Malaysian car like Kancil or Perdua Myvi. Then the total chassis weight must be lighter than 83 kg. Then the chassis can produce torsional stress higher than 2363 Nm per degree. So all the value that I stated there is I get from all my research. Doing my research, I get all this value, and it can be it's stated in my literature review. So this is all the literature review that I get, 11 in total, to complete my project from chapter 1 to chapter 3. So the objective of doing this literature review, first thing is I need to get the relevant parameter to design the chassis, especially for electric, because it have additional structure or compartment or surface that we need to add the battery pack area for the chassis itself. And then I used to study about the design, the design principle, and then I need to find the better materials that I want to use to design the chassis. Especially my objective is to design a lightweight chassis, so I need to find a better material that can provide lightweight but still relevant for the chassis to withstand the stress, to support the vehicle body, vehicle component. And then the another parameter that I get from literature review is a type of chassis that I've used, that I will use or I will design to this project. That there are many type of chassis like leather chassis, space frame, monocoque, backbone, and all these design I've studied in my literature review, and I've select a design, a type of chassis that I think it very suitable for electric vehicle, which is space frame chassis, due to its structure that have many cross member, that I think it very rigid, and then I think it have lightweight because of the it have a hollow structure of hollow pipe, so it can provide lightweight structure. So all the conceptual design that I've decided when I do the literature review, we can see on my methodology. There are also a few things that I review from all this paper. The thing is, I see the method, the relevant method to do the analysis, and I find out that many researchers do the analysis by doing finite element analysis and software use. There are a variety of software use, but for me personally, I would like to use SolidWorks for my design. So after complete doing my literature review, so I managed to produce my own flowchart. After collecting literature review, the parameter selection. So for the parameter, there are two types of parameter that I select, which is type of chassis, and I choose space frame as the chassis. And then type of material, I choose stainless steel AISI 1020 types of material. Then the development of conceptual design. So there are 9 orientation that I made for the conceptual design, which is there are 2 parameter that I manipulated, which is second is battery position, that can be shown at this picture. The blue box is considered as battery position. And then the second thing is the geometry of the chassis, which is for chassis B and chassis C, there are added structural cross member or structural geometry. The chassis B like this and chassis C like this. So the 9 orientation I made for the conceptual design. And then to before do the analysis, like usual, need to creating global mesh using SolidWorks or ANSYS. Then analyze if the global mesh have no error or any problem, I can analyze result. If no, I need to do my conceptual design, or need to create need to redo my global mesh. Then my analysis result, this is the example of result analysis of torsional stiffness. And then the last thing is establish of final design. So the expected outcome for this project is all the 9 orientation are analyzed using SolidWorks to get the best value of torsional and bending stiffness. So the expected value of the final stiffness is, as I mentioned on scope project, the value is to 363 Newton meter per degree that I get from the literature review. And then for this experiment, for this study project, because of I use triangulated design as my geometry design, so I need to prove that whether true or not the triangulated design can produce high stiffness. So that's why I used to that we can go to this methodology. There is no not much triangulated design, and for these two chases, I need to put more triangulated design. So the result can get from this analysis later. So um, I need to prove that a model with triangulated design can produce high stiffness. Overall project rank, which is my Gantt chart. So this is my Gantt chart. So my name is Nurul Aisha binti Ramlan. That's all from me for this video. Thank you.